Problem 3 is a lot longer and a lot harder. Here's how it is. We have the following. If f of x is given by the following expression, it's equal to x cubed minus 3 half x squared minus 18x For example, this graph, over here it's concave up, over here it's concave down. So somewhere between there's a point where it changes. Right about there, to the left we say it's concave up, to the right it's concave down. So the point where it changes is said to be a horizontal point of an inflection. We want to be able to find these points. To find these points we have to run several tests. Almost always more than one test is needed to determine them. The first test just gives candidates, and the additional test will actually tell whether we have relative min, max, or point of inflection. In order to understand these tests, we have to define something called critical value. A number is a critical value for x. I should actually write here, given a function f of x. Given the function, you have to have the function first. A number is a critical value for x if one of three things occurs. If one, I should say that, f of x is not defined for this value. For example, I have the function f of x equals x over x minus 2. If x equals 2, the function f is not defined. Therefore, the value 2 would be called a critical value of x for the function f. That's an example. That's the first type of critical value. There's three types. The second type is f of x is defined, but f prime does not exist at this value. This value. We get an example of such a function also. The function f of x was the absolute value of x. Graph of it looks like, I'm going to draw this graph in color. Graph looks like a V. If I approach the origin, 0, 0, from the right, the slope of the tangent line appears to be +1. If I approach the origin from the left, the slope of the tangent line appears to be -1. There is no tangent line at the origin because the two slopes are different. There are many lines that touch the graph and only one point. For example, This line touches the graph from only one point, so does this line, so does this line. They are not called tangent lines by definition. The tangent line has to be unique, and there's only one tangent line when it exists. There is no one tangent line, one unique slope. Therefore, at the origin, this function f called absolute value of x does not have a tangent line. The tangent line does not have a slope. That means it does not have a derivative. So when the value of x equals 0 is a critical value because when x is 0, the function f does not have a derivative. That is, f prime of 0 does not exist. That's the second type of critical value. The value for x where the function exists, but f is defined, but the f prime of x does not exist. A third type of critical value is f of x is defined and f prime of x does exist, and f prime of x equals 0. If you have a function where f is defined for this value of x, and f prime exists for this value of x, but f prime of x is 0, then we have what we call a critical value for x. A simple example of this would be f of x equals x squared, a parabola. F prime of x equals 2x. And when does that equal 0? This equals 0 if and only if, how to abbreviate it, x equals 0. So at the point x equals 0, we have a tangent line like this, which is 0. It has slope 0. The tangent line has slope 0, meaning it is horizontal. The tangent line has a slope which is horizontal. The value for x that gave me that tangent line, which in this case was 0, is a critical value for x. That means the point here is a relative max or minimum. It does not mean that. It means this is a candidate for being a relative max or a relative minimum.
Because the graph could still potentially go down.
No, I'll explain that. No, that's not the reason why. I'll explain it in a minute, the reason why. This is a candidate. In this case, this is a relative minimum. But the tangent line is flat. There's a good possibility that the graph would either have a minimum there or a maximum. Minimum maximum means the value of f, not the value of x, not the value of f prime, but the value of f is a max or a minimum. You say max or minimum, we're talking about the value of f of x, the value of y. Talk about critical value, we're talking about the value of x that causes that value of y to take place. So this is a candidate. Now, why is it it might not be a max or minimum? If I look at the function f of x equals x cubed, I tried drawing it. I'm going to draw this in color so you can see it. It looks very interesting. The function is coming down like this. It looks like I'm going to have a minimum there, but instead of going back, I would think the function might go back up, but it doesn't do that. Instead, the graph goes like that, sort of a reversed S. If I take the derivative, f prime of x equals 3x squared, and this will be equal to 0, again, if and only if x equals 0. Since f prime of x is 0, when x is 0, that means the value x equals 0 is indeed a critical value for the function. But this is not a max nor a minimum. This is what we call a point of inflection because it's concave up to the right of 0, and when x is to the left of 0, it's concave down. So it changed. Whenever you see f prime of x is 0, it does not necessarily mean it's a max or min. It could be something else, for example, a point of inflection. And the general test to test for point of inflection is you want to look at f double prime of x. That is 0. So what's f double prime? That's going to be the derivative. This would be 6x. So 6x equals 0. That means x equals 0. So if f single prime is 0, and f double